Hello students. Today let us recapitulate concepts of perimeter and area of circle. As you already know that perimeter of closed figures is defined as the length of its boundary. But when it comes to circle, the perimeter is called the circumference of the circle. If we cut the circle and unwind it, it forms a straight line. Then the length of the straight line is nothing but its circumference. You are already familiar with some methods of finding perimeters and area of simple plane figures such as rectangles, squares, parallelograms, triangles. For example, perimeter of square is sum of its 4 sides or 4 into s. But to calculate the circumference of the circle, knowledge of a term known as pi is required. Consider the circle with the center O and radius r. In this, pi is equal to c upon d, which is equal to c upon 2r. As you can see, pi is the ratio of circumference of a circle to its diameter. Students, note that this ratio of circumference and diameter is constant for every circle, which means no matter how big or small circle is, the ratio of its circumference and diameter will always be pi. Therefore, if c is the circumference or perimeter of the circle and d is the diameter of the circle, then we know that pi is equal to c upon d. Therefore, c is equal to pi into d, which is equal to 2 pi r, as d is equal to 2r. Now let us see area of circle. The area covered by one rotation of the radius of the circle on a two-dimensional plane is the area of that circle. Now, how can we calculate the area for any circular object or space? In this case, we use the formula for the circle's area. Recall that formula for area of circle is pi r square. So let us derive the formula for area of the circle. For that, take a circle with radius r. Then, as you know, the area of the circle A is equal to the product of pi and square of the radius. That is, A is equal to pi r square, where pi is equal to 22 upon 7 or 3.14 and r is the radius. Area of circle can be visualized and proved using two methods, namely, first, determining the circle's area using rectangles, and second, determining the circle's area using triangles. Let us understand both the methods one by one. Recall that you have learnt to divide circle into smaller equal sectors. Now arrange the sectors like this. Observe that it forms a parallelogram. So we can say that the area of circle will be equal to that of the parallelogram formed by the sectors cut out from the circle. As you can observe, the red colored sectors will contribute to half of the circumference and blue colored sectors will contribute to the other half. Also, observe that breadth of parallelogram is equal to radius of the circle. Now, if the size of sectors are still made smaller and smaller, we find that the parallelogram will eventually look like a rectangle with length equal to pi r and breadth equal to r, and the circumference of the circle is equal to the sum of two lengths of rectangle. That is, c is equal to pi r plus pi r, which is equal to 2 pi r. And also observe that breadth of rectangle is nothing but radius of the circle. Therefore, for rectangle, we can say that length is equal to pi r and breadth is equal to r. Therefore, the area of rectangle will also be the area of a circle. So we have area of circle A is equal to area of rectangle, which is equal to length into breadth. On substituting the value, we get pi into r, which is equal to pi r square. Therefore, area of circle is equal to pi r square. Now, let us derive area formula using areas of triangles. For that, fill the circle with radius r with concentric circles. Cut all the concentric circles along the indicated line and unwind them as shown. We observe that it will be a triangle. Here, as you can see, that the base of the triangle will be equal to the circumference of the outermost circle, and the height of the triangle will be equal to the radius of this circle. Now, here also, area of the triangle will be equal to the area of this circle. And we know that area of triangle is half of the product of its height and base. Therefore, A is equal to half into height into base. Here height is equal to r and base is equal to 2 pi r. On substituting the value in formula, we get A is equal to 1 upon 2 into r into 2 pi r, which gives us A is equal to pi r square. Therefore, we can say that area of circle is equal to product of pi and square of its radius, that is pi r square. Now, let us solve some examples related to it. Example 1. The area of circular playground is 22176 cm square. Find the cost of fencing this ground at the rate of 50 rupees per meter. Here, we are given area of playground and we have been asked to find cost of fencing of this ground. So basically, we are asked to find the perimeter or circumference of this circular playground. So first, let us find radius of circle from given data. That is area of circle, which is 22176 cm square. So let the radius of playground be r centimeter. Therefore, area of circular playground is equal to pi r square. On substituting the value, we get 22176 is equal to 22 upon 7 into r square. Therefore, r square is equal to 22176 into 7 upon 22. On simplification, we get r square is equal to 7056. Therefore, r is equal to root of 7056, which gives us the value of r 84 cm. Now, let us calculate circumference. The formula of circumference of the circle is equal to 2 pi r. Now, after substituting the values, we get 2 into 22 upon 7 into 84. On simplification, we get value of circumference as 528 cm. Now, to find the cost of fencing of ground with perimeter of 528 cm, multiply it with the cost of 1 meter. So, first, convert circumference from centimeter to meter. Therefore, we get C is equal to 5.28 meters. As to convert centimeter into meter, we divide centimeter by 100. Now, rate of fencing is equal to 50 rupees per meter. Therefore, total cost of fencing is equal to 50 into 5.28, which gives us 264. Therefore, total cost of fencing the circular playground is 264 rupees.